Number 10. What is the mass in grams of 100 atoms of the carbon-12 isotope? Well, again, I'm going from a number of atoms into grams, and if we peek up at the work we did on number 9, I talked about this idea that we can't go straight from grams into atoms. Similarly, we can't go straight from atoms into grams, which is more like what number 10 is asking me to do. I'm going to have to go through moles first. I'm just going to have to set up 2 conversion factors to make this happen. Now I have 100 atoms exactly. Yeah, that's important here. I have 100 atoms exactly. Remember Dalton's postulates for it, his atomic theory, atoms cannot be created, destroyed, or subdivided. Remember, under normal chemical means, these atoms can't be subdivided. So when we say 100 atoms, you got yourself 100 atoms. That's an exact number. We're not going to let those 3 digits, or I guess 1 significant figure, as a measurement, not affect our significant figures in our answer. So that's an exact number. It's a count value. Don't sweat it. So we're going 100 atoms, carbon-12. We can convert from atoms of carbon-12 into moles of carbon-12. Then from moles of carbon-12 into grams of carbon-12. All right, and it looks like both of those atoms will cancel. Both of those moles will cancel. And my answer will be in terms of grams, like the question asked for. So let's plug these in. I know that for every 1 mole of anything, I have 6.022 times 10 to the 23rd of those things. Okay, and I know that for every 1 mole of carbon-12, I have 12 grams. You might be thinking, what about the periodic table? What about the 12.011? This is an isotope, y'all. This is the type of carbon that has a mass of 12, right? There is 6 protons, 6 neutrons in there. That mass is 12. Plug this in the calculator. 100 times 12. That's the hard part right there. And then divide by 6.022. I'm going to come up with 199. Let's see, I want 1, 2. Okay, well, that's exact as well. That has 4 significant figures. I'll go with 4 significant figures. I'll go 199.3. But I also have this times 10 to the negative 23 here. Why is it times 10 to the negative 23? Because my exponent here, the 23, is on the denominator, and there's no exponent on the numerator. So I'm going 0 minus 23, which is negative 23. Now, I'm not done here yet, even if I write grams of carbon-12. It's because this is not in proper scientific notation. I would need to move that decimal 2 places to the left in order to accomplish that. So if I want to record the correct number of significant figures in proper scientific notation for this calculation, I'm going to write 1.993 times 10 to the negative 21st grams of carbon-12. Box out your response, and there's your worksheet, y'all.